In this video I'm going to show you guys how you can graph polynomials from factored form. And actually I think it's a little bit easier to do it from factored form than if it was written in standard form. The example I'm going to show you guys is, let's let f of x be 1/6 times x plus 3 times x minus 2 quantity squared. So you'll notice the polynomial was given to you already factored, and because of that it's easy to find the x-intercepts. So when I write down the steps, step 1 is know what your x-intercepts are and plot those. So for this one, I know my x-intercepts come from setting x plus 3, that factor, equal to 0, and that gives me an x-intercept of -3. And I have two factors of x minus 2, really. I have an x minus 2 that I can set equal to 0, and another x minus 2. Let's actually not write that there. Let me write it just maybe below. But if I solve x minus 2 and set that equal to 0, I get 2. And really, I could do that twice, right? Because it's squared. So there's really two factors of x minus 2, which means there's two zeros. It's a repeated 0 at 2. So when we plot, the x-intercepts, we want to keep in mind cuts, meaning there's only one 0. There's kisses, remember, that's if there's an even number of repeated zeros, and then there could potentially even be little kiss and go action, and that's if there's an odd number of repeats. Now in this case, because I only have one 0 at x equals -3, I know that is going to just cut through the x-axis at that point. But for this guy, do you see how I have two zeros at 2? That's an even number. Not the actual number 2 itself, although of course that's even, but the fact that there's two solutions there makes it a kiss. So when I plot -3, that's going to be right here, and when I plot 2, that's going to be right here. I know this is going to be a kiss. Sometimes I even like to label it, and this is going to be a cut. So that's step 1. Now step 2, I like to keep in mind my end behavior and just make a little sketch. Now because it's written in standard, or it's not written in standard form, it's not quite as obvious what the degree is, but all you have to do is count the number of factors with an x. So count the number of factors with an x in it, and that will tell you the degree. So since I have, an x minus 3, and then I have an x plus, or excuse me, it was x plus 3 and an x minus 2. There's an x minus 2, but there's really two x minus 2's, right? There's 1, 2, 3 factors with an x. I know my degree is 3, and the leading coefficient is positive. So my end behavior, if it's odd and positive, I know is going to go up there and down here. So that's going to help kind of save me some time as well. Maybe the toughest part is step 3, which is to plot points between the x-intercepts. Okay, so what we're going to do here is I'm going to see if I can squeeze in a little bit of a table. If I make an xy table, between the x-intercepts I can plug in a few things. I can plug in 0, I can plug in 1, I can plug in -1, and I can even plug in -2. So those would be the coordinates I would try to plot. And really, you don't need to plot all of those. Just plotting a couple to give it its shape will help. So if you were to plug in 0 here, the function turns into 1/6 times 0 plus 3, and then it would be 0 minus 2 quantity squared. So really it'd be like 1/6 times 3, and then negative 2 squared is 4, so it's a sixth of 12. I think that's just 2. So when I plug in 0, I get 2. That would be this coordinate right here. Let's plug in negative 1. To me, that seems like the next thing I'd like to do. If I plug in negative 1, it's going to be 1/6, and then negative 1 plus 3. And then I got negative 1 minus 2 quantity squared. So that's going to be 1/6. Negative 1 plus 3 is just 2. And then negative 1 minus 2 is negative 3, but I got to square that. That's going to be positive 9. So it turns out to be 1/6 of 2 times 9, that's 18. A sixth of 18 is 3. So when I plug in negative 1, I get 3. And actually, I kind of know what's going on now. You may not. You see these points. But realize, your end behavior, you know you're going to cut through the x-axis and go down like that. Okay? And you know at some point you're going to be going up, and away in this direction as well. What I'm going to do is just kind of make a smooth curve that goes through the points I have plotted and cuts through the graph at negative 3 and is going to go through these coordinates, and I'm going to carefully kiss the x-axis at 2 and then just go with the end behavior. Now granted, will some of these coordinates be off a little bit? Sure. Is some of the coordinates off here maybe a little bit? Yeah, maybe. But this gives us a very good idea of what this polynomial looks like without, having to plot every single coordinate. But I would expect to see this when I'm grading this. I want to see, the intercepts graphed, and also when the polynomial is graphed, that it cuts appropriately and kisses appropriately. And I'm going to look for at least, so let me maybe write this down. You want to plot at least 1 point between x-intercepts. And so in this graph, since I only have, these 2 intercepts, I plotted 2 coordinates. So, that's good enough. I could have gotten away with just 1, but I think it was such a big gap between the 2 intercepts, I wanted to plot more than 1. And so that's it. I'll let you guys practice a few and get some questions going. Thanks for watching.